Are you tired of having tons of dependencies in your scripts and constantly having to resolve them? Then you should use Extenject, which will take care of all of this. Extenject, previously known as Zenject, is a popular dependency injection framework made specifically for Unity. If you are unsure about what dependency injection is, then I recommend you to watch my tutorial about it, but in short, dependency is some class or some other object on which a class is dependent. So in case of the player is dependent on the score manager, and injection means that the dependency should not be resolved inside of the script, so the player itself should not be taking care of how it gets the score manager, but it should receive it externally. And this is exactly what the dependency injection framework will do for us, is that it will just inject dependencies into our scripts without us having to do much work. To download Extenject, just go to your internet browser, search for Asset Store, open the first link, and then just search for Extenject. Scroll down and open this asset. You can see that it is free, so anyone can use it. You can just hit Add to My Assets, hit Open in Unity, and in the Package Manager, you can just download the package and then import it into your project. Now as we have Extenject imported, let's jump into the player script and let's try to resolve the dependency of the score manager that we have. So this one I will make it private, because I don't want to be setting it through the inspector, but I want the Extenject to handle it for me. To use any of the functionality of Extenject, we just need to add using Zenject, because this is how it was called before. And the way that we tell Zenject that we want it to resolve this dependency for us is using the inject attribute, so we can just add it in front of the variable. What you see right here is one of the 4 types of injection that Extenject allows us to use, which is the field injection. The same way we can use property injection, but these two are not that common. The 2 types of injection that we will be using the most likely is the constructor injection, which you can use only in non-mono behavior classes, because mono behavior classes cannot have constructors, and the second type you will most likely be using in mono behavior classes is a method injection. So for this, we can create some kind of function which will be used to initialize all of the dependencies. Instead of the field injection, I will be using the method injection, because it is just all in one place, which usually is a lot better. So most of the times we will be using just the method and the constructor injection, and here again we are using the same attribute, the inject. So this is the method injection, really simple. So now, as soon as we start the game, Zenject will look for all of the properties and the fields and the methods marked with the inject attribute, and it will try to inject all of the dependencies. Now, we haven't yet told Extenject how it should resolve the dependencies, so we need to tell it whether it should take the score manager from some object in the scene, or whether it should create new score manager, and so on. Defining how each of the dependencies will be resolved is done in so-called installers, so I will just create a new script. The typical name is game installer, but you can call it however you want, and you can have as many installers in your scene. As I said, in this one we'll tell it how it should resolve the score manager dependency. Again, we need to add using Zenject, and it's not going to be mono behavior, even though it will still be inheriting from mono behavior. Instead, it will be mono installer. So this is still a mono behavior, but we have some additional functionality so that we can define how each of the dependencies should be resolved. There are also other types of installers, such as the installer, which is non-mono behavior, and there is also scriptable object installer, but I won't be covering these ones in this tutorial because it would be an hour-long tutorial. If you are interested in learning more about Extenject, then you can check out my Patreon, where soon I will be releasing a more in-depth tutorial about Extenject, where I will cover scriptable object installers, non-mono behavior installers, optional and conditional binding, some interfaces like iDisposable, iTickable, and much more interesting stuff that you can do with Extenject. For now, we'll stick to the classic mono installer, so we won't be using any of the Unity functions. Instead, we'll override the void we have, which is install bindings, and inside of this one, we can tell Extenject how it should resolve each of the dependencies. So all of this will be happening inside of a container. The container will be storing all of the bindings, so when one of the other scripts, let's say, wants to inject some score manager, the container will know how to resolve that, so whether we should take it from some existing object, whether we should create new object, and so on. So here we can use the function bind, then we'll use the type which we want to bind. So in my case, as I'm injecting the score manager, it will be the score manager. What this is saying is that whenever some of these scripts wants to inject the score manager, it is just going to create new score manager. This would work with a classic class, but because this is a mono behavior and we cannot instantiate it without an object, it would not work. So we can change some methods on it. If you want to tell it from where it should get the instance that it is then going to inject, you are just using one of the many from functions. In this case, we could say from new component on new GameObject. Let's jump back to Unity, and there is one more thing that we need to set up, which are contexts. Using contexts, you can group or separate all of the dependencies pretty much into individual groups. There is a project context, which is just for the whole project. There is a scene context, just for the scene, and GameObject context for the GameObject. Right now, the most classic one is the scene context, so I will create new empty object. Here we can do add component, search for the contexts, and you can see there are 4 of these. So this time let's use the scene context, and let's also add the installer, because if we don't add it anywhere, the logic we have inside is not going to run. And here you can see that we can assign the installers, so we have the scriptable object installers, the mono installers, which is what we are using right now, and we also have some prefab installers. And before you start the game, Extenject also allows us to simply check if we have successfully resolved all of the dependencies, because what could normally happen is that you forget to resolve some of the dependencies, then you start playing the game, and only after, let's say, 10 minutes of testing, you found out that you have forgot to set something. So the way you can test this is by going to edit, Zenject, and we can say validate then run, which is going to validate if all of the dependencies are successfully resolved, and then it's going to run the game. You see that there is also a shortcut, Shift, Alt plus R, so I can press it, save it, wait, and you can see that Extenject warned us that we didn't define the scope. So we'll have to go back into the installer, and let's talk about the scopes. With any of these bindings, we can chain one more function, which is S. Then we have either S-cached, S-single, and S-transient. These are the scopes that Unity was talking about. S-transient means that for each injection, it will create new instance of the score manager. So in this case, this is not really something we want. We don't want to create new score manager for, let's say, each new player. But what we can use is the S-single, which will just reuse the same instance for each injection. As soon as I start the game, we can see there is new score manager created. I already had one on the canvas, and it created new one in here. But right now the issue is that the score manager also has a dependency on the text. So in case of the score manager, it is not really wise to be creating a new one, because we can already preset it in the scene. So instead of creating new object and adding the score manager component, we can just take it from the instance that already exists, which in my case is placed on the canvas. So instead of using this binding function, we can say that from instance. Then we also need to provide it with the instance, so from where should we get the score manager? I can just make a simple serialized field. Yep, we are getting no more errors, so every time some script wants to get a score manager, we'll just get it from this instance. Now this may seem like the same approach that we had in the player before, that we just had a variable that was serialized field where we could assign the score manager in the inspector. But let's imagine that you have tens of players, and for each one of them you would need to assign the score manager. That would be quite annoying. So what we are doing right now is that we assign the score manager just once, and then it gets injected into all of the other scripts. Back in Unity, don't forget to assign the score manager, so I will just drag in the canvas on which it is. Try to validate. We are getting no errors, and let's try picking up these coins. Yep, we can see that the score is increasing in the top right corner as it should. And if we ever need to access the score manager anywhere else, we can just use the inject attribute and we don't need to worry about anything else, we don't have to assign it anywhere. Let's say that we don't want to be assigning the score manager through a variable like this, but instead we want to just find it in the scene and then assign it. So for this we can use the function from component in hierarchy, which will just search through the whole hierarchy and try to find us the score manager. Again, we can say that we want to get it as single, but in this case it does not matter as much. I also want to talk about two other functions that we have. which are the lazy and non-lazy, where lazy means that it's going to resolve the dependency as soon as some object requires it. So if we would never need the score manager and we would be using the lazy loading, it would really never even try to find it, because we don't need it. And the non-lazy is the exact opposite, so it's going to resolve the dependency from the start, so at the start it will search for the score manager and later provide us with the instance that it has already found at the start. And we can see that this is working the same way as before, except that we don't have to assign anything in the inspector, it works all automatically. Let's take a look at another example, which is spawning some enemies. So I've just created an empty object and placed the enemy spawner on it. This script is not supposed to be doing much, it is just going to get some enemy, which will be the enemy we want to spawn. So for this I have created a simple interface, which just has one function, and from this we are extending the skeleton. Again, nothing fancy, just the interface and the attack function, and I also have a zombie. So to the enemy spawner I want to provide some enemy that I want to spawn, and then on start it should just create new object with that enemy name, and if the enemy to spawn is mono behavior, we can just add the component on it. Working with interfaces is a bit inconvenient, because we cannot serialize them in the inspector, so we would just need to provide it in a different way. Instead of making this variable serialized field, let's just inject it through the method. Do not forget the inject attribute. Now we'll jump to the game installer, and we'll just say which enemy we want to bind with the enemy interface. Again, let's say container.bind. Now we are not binding anything to a specific class, but this time we are binding it to an interface, which is enemy. And like this, the Extenject doesn't really know what to do, because we haven't told it what exact script we want, we just told it which interface we want to bind with something. So we can use another function, which is to, and here we can specify to which class you want to bind that interface. So in my case, let's say that I want to spawn a zombie, and again we should tell it if we want it as single, which I don't think we want in this case, because if we instantiate multiple enemies, we don't want to be reusing the same class. So let's use the as transient, which will just create new instance every time. And yep, we can see that in the hierarchy it has instantiated an object, test extenject.zombie, and it is no surprise that we don't have any component on it, because in the zombie class itself I did not specify it as mono behavior, but we can see that it correctly chose the zombie as we told it in the installer. Let's say that you would have some enemy spawner, but then you may also have some boss spawner. So in the boss spawner you probably don't want to be spawning some basic zombie, but some kind of zombie boss or something. So in this case what we can also do is use another method, when injected into, which will just allow us to limit to which class you want to inject the zombie. So let's say that when it is injected into the enemy spawner, only then we want the enemy to be zombie. And then later, as we create the boss spawner, here we could bind the enemy with some zombie boss, and we could use it only when it is injected into the boss enemy spawner. Let's take a look at a bit more complicated example. Again, it is just some enemy spawner. We have some delay, some position as for where we want to spawn the enemies, some prefab for the enemy we want to spawn, and then in the start function we just have a simple loop. So it is generating some random position, then it is instantiating the enemy, then waiting for the delay, and so on and so on. I want to provide each of the enemies with some armor, so for this I am using a armor factory. I'm also storing the current armor of the enemy, and the way I'm getting the armor is really simple. I'm just getting some random armor type from the armor type enum I have, which is again just a simple enum. Right now I have just some plate and some leather armor, so we are just generating the random armor type we want to get, and then we are calling the create function in the factory, which will get us the armor based on the type, and then I'm just calling the function receive damage, which will call the function inside of the armor, which will just tell us which armor it is. So the leather armor is inheriting from the eye armor, it has some protection, and mainly it is telling us what the armor is in the console, and for the plate armor it is really the same, we have just different text. For the interfaces it's really simple, just the eye armor and the eye armor factory, and the factory itself is again very simple, it is just taking in the armor type, and based off that it is creating us the class. With this setup, we could create different armor factories. So let's say that in our game we have some Halloween event, we have some Christmas event, and in each of these events we want to provide the enemies with different armors. We could definitely just set it in the inspector, so for all of the enemy spawners we would need to choose a different armor factory, or we could have some kind of a manager which would just go through all of the enemy spawners, it would assign the factories, but what we can just tell it is that when any enemy spawner, or rather the enemy, requires some factory, we'll just provide it, let's say with the Halloween armor factory, something like this. The way we use factories with Extenject is a bit different, because they have their own factory interface. So let's start by including Zenject, and to make the factory work, we won't really need our own factory interface, such as the iArmor factory. So let's remove this one. We can delete the iArmor factory interface as a whole, and instead we'll inherit it from iFactory, which is interface provided by Extenject, and then we can give it multiple values. First, we are giving it the inputs of the factory, where in my case the only input is the armor type, and the last parameter has to be the product, so it is the outcome of the factory. In my case this is just some iArmor, just like so. Then back in the enemy, as we need the factory, we won't be using our own interface, but the iFactory, so again we need to add using Zenject, and I will just mark it with the inject attribute, so that Extenject takes care of it for us. And then in the start we can just use the armor factory to create the armor the same way as before. And the last thing missing is to go into the game installer and specify to which exact implementation of the factory we want to bind it. So again we are using the container for that, we can use bind iFactory. Here as for the contract of the factory, this is the same as how we have defined the factory. And if we want to bind it to a specific implementation of that factory, we can say from factory. Right now I have just one armor factory, but as I said, you could have some Christmas armor factory and all of that fun stuff. So we start the game, we can see that some enemies are spawning in. So let's check what the console is saying. I can already see some red error, and this is telling us that there is some object reference missing inside of the enemy script. So let's check that, and it is on the line 18. So the only thing that can have a reference missing on this line is the armor factory. But why is that? We have provided it with the inject attribute, and inside of the game installer we have binded the factory to some concrete implementation of the factory. And the reason for that is because we are instantiating the objects dynamically at runtime, not at the start of the game. Then Extenject just doesn't want to resolve the dependencies for us. And the way we can fix this is to instantiate the enemies inside of the container. So when you are instantiating any objects and the objects have some dependencies, you need to use the container, but using it is really simple. We just need a variable for it, then we need the function which is going to inject it, so either the method, or we could just add the attribute directly in front of the container. And then instead of instantiating the object the classic way, we'll instantiate it using the container, so container.instantiate prefab. So this way Extenject will know about the enemies and it will be able to resolve their dependencies as well. Yep, we can see it is spawning some enemies. One of them has leather armor, the another one has leather armor as well, another leather armor, but then we can see that one of them has plate armor. Again, we have quite many leather armors. This is just the way that the random in Unity works, but these ones have plate armors as well. So we can see the enemies are getting randomly assigned some armors that they are getting from the factory we have assigned, which right now all of them are using the armor factory. If you are looking for the project files, they will be on my Patreon, and you can be looking forward to the next video that will also be on my Patreon, which will be explaining the Extenject more in depth. Or you can just check out the video that is already out, where I will show you how to create a simple to-do list application from start to finish, and we will be using the dependency injection as well, the MVC and the command pattern all together. Now you can see the true power of Extenject. Before I looked into it, I was thinking that I don't really need to use any of these frameworks, that I can make it all on my own, but now I see the potential benefits of using Extenject, that it could really make my life a lot easier. And there is a ton more stuff I didn't go through, so if you want to learn more about it, you can also take a look at their GitHub, where they have really great documentation. So Extenject is a great library that I think can fit almost any project. If you are looking for some game developer friends or just seeking help, feel free to join our Discord server. Also take a look at my Patreon. I hope that this video was useful. If you have any questions or suggestions, drop them down in the comments. Don't forget to like, subscribe, and I will see you in next videos. Bye!